There's a simple truth that most gardeners learn the hard way. A cold compost pile will stay cold no matter how much you poke at it, turn it, or pray over it. People build beautiful piles, full of kitchen scraps and yard debris, only to watch them sit there like a damp, lukewarm mess for months. The secret they're missing is the same one old farmers used long before thermometers, insulated bins, or fancy compost activators. They used one additive, an ingredient so basic, so overlooked, that modern gardeners often toss it out without a second thought. This single material wakes up a cold compost pile and pushes it into natural heat, even in cool seasons. Stay with me for the first minute, and you'll understand not only what it is, but why it works, and how you can use it to turn even the laziest pile into a steaming powerhouse. The ingredient that wakes up a cold pile is high-carbon dry matter added in the right form. Yes, the world talks endlessly about greens and browns, but the missing piece for most struggling composters is shredded brown material. Specifically, very fine, dry, high-carbon matter like shredded leaves, torn paper fibre, or finely crumbled straw. The smaller and drier the carbon source, the faster bacteria can latch onto it. Cold piles stay cold because they contain too many wet scraps and not enough surface area for microbial expansion. Bacteria need a structure they can grip onto, multiply within, and heat from the inside. When you introduce finely textured carbon, you're essentially giving the microbes a scaffolding system. It's the same principle that allowed ancient farmers to compost manure and straw in winter, producing heat strong enough to start seedlings early. The chemistry that makes this additive produce heat is worth understanding. When you add fine dry carbon, you change the carbon-to-nitrogen ratio instantly. Microbes that were previously starved of structure now receive the fuel they need to reproduce rapidly. As they multiply, they release heat. This isn't just warm compost. It's the same microbial heating that powered old French hotbeds, where gardeners packed straw and manure into frames that warmed the soil above. That combination worked because of the carbon-heavy structure. The manure supplied nitrogen, but the heat came from the carbon decomposing at high speed. In your modern compost pile, food scraps take the role of nitrogen, but without carbon flake structure, the microbes never gain enough mass to fire up. The reason shredded texture matters more than the carbon source itself. Whole leaves, branches, cardboard sheets and straw stalks don't work well because they break down too slowly. They trap air and create pockets, but they do not ignite microbial activity. Shredded carbon behaves differently. It gives you thousands of contact points per handful. The smaller particles absorb moisture from food scraps, balancing the wetness that normally suffocates bacteria in cold piles. This creates the perfect middle ground between moisture, oxygen, and fuel. If you've ever wondered why a pile of raked, shredded autumn leaves heats up on its own, even without kitchen scraps, while whole leaves stay cold for a year, this is the exact reason. Here is how to apply this method to wake up a dormant compost pile. Start by collecting fine carbon sources, shredded leaves, torn newspaper, or finely crumbled straw. The easiest and most historically reliable option is shredded fall leaves, which were the backbone of winter composting for centuries. Add a full layer of this material directly onto your cold pile. Don't sprinkle it. Bury the wet kitchen scraps under it. The goal is to create a thick cap of fine carbon that absorbs moisture from below. When moisture wicks upward into this additive, it starts the bacterial expansion. Within a few days, you can push your hand into the pile and feel warmth returning. Within a week, the centre will often become hot enough to release steam on cool mornings. If the pile still struggles, add a second dose of shredded carbon and lightly mix only the top 6 inches. You're not turning the whole pile, you're giving the microbes a fresh runway near the surface. This method works even in cool climates or inactive seasons. People often worry that compost won't heat in winter or the shoulder seasons. But remember that traditional farmers relied on winter compost for both soil fertility and greenhouse heat. Their secret wasn't warm weather, it was carbon density. When a cold pile receives enough fine carbon, internal heating begins regardless of outside temperature. The microbes generate their own heat through rapid reproduction. This is why a forgotten pile of shredded leaves under snow can melt its own cavity while the air is freezing. The same principle applies to your compost. You supply the structure, the microbes take over the furnace. The practical results you can expect once your pile begins heating. A warming pile breaks down faster, smells better, and collapses in on itself as the internal material digests. You'll see the pile shrink as the centre transforms from colourful scraps into dark, uniform soil. Your beds will feel the difference as well. Hot composted humus carries a richer nutrient profile and a finer texture than cold processed material. It blends into the soil more easily and supports bacteria and fungi that bond with plant roots. This means healthier seedlings, stronger root development, and soil that stays moist longer without becoming heavy or muddy. If you're serious about building soil the way old farmers, settlers, and early horticulturalists did, this one additive, finely shredded brown matter, belongs in every compost pile you build. It's the difference between a lifeless heap and a living engine of fertility. If you found this breakdown useful, subscribe to Farm Logic and share this video with anyone trying to revive a stubborn compost pile. More practical, historically grounded soil wisdom is coming your way.